The next question of CodeChef starters 120 is construct permutation. So in this question, we are given N and K. So we have to find out any permutation P which satisfies the following criteria. That is summation of I1 to N of max of j is equal to 1 to I P of j minus minimum of I j is equal to 1 P of j is perfectly equal to K. So we should find out any one permutation which satisfies the following equality. So here there can be multiple permutations also. If there exist multiple permutations, we can print any one. And there can be a scenario for a particular N and K, there might not exist any permutation also. So in case if no permutation exists, then print -1. So if you look at the constraints of this question, test cases can be in the range 1 to 10 power 6. N can be in the range 1 to 10 power 6. And K can be in the range 0 to N square. And summation of N over all test cases won't exceed 10 power 6. So this is what the constraints are. Let's see how we can solve this problem. So let's see how we can solve this. So firstly, let's handle a simple case, that is when N is equal to 1, perfectly 1. Then only valid value that we can have is K is equal to 0, right? So N is equal to 1, and if K is equal to 0, we can just output 1 in this case. Else, other than this, no matter which K we have, output will be -1, right? For sure. Because it's impossible to make a array or make a permutation whose summation of the following equality gives perfectly K. So now we know N is equal to 1 is handy. Now let's formulate something for all the N's greater than 1. For all the N's greater than 1. Firstly, let's make some observation and then formulate it. Right? So the observation is we have some permutation, and here let me write down the equality over here. 1 to N. P of K, right? So if this should be perfectly good. So if we observe this, if we consider this, let's say we have a permutation P1, P2, so on to Pn. Then my claim is for sure for the whole permutation, maximum of Pj minus minimum of Pj will always result in n-1, right? For whole permutation. So let us write it in reverse fashion. Pn, right? So here at this point, the maximum value in the permutation minus minimum value in the permutation till this point will be n minus 1 for sure, if you observe, because every number will occur exactly once at this point. Now, when we are over here, it depends on what number we kept over here, right? So let's say in case I kept n over here, then we can say over here the value will be maximum of pj minus minimum of pj will be n minus 2, right? In case if I don't put a n, and if I put any other number apart from n and 1, if I put any other number, then we can say that the value will be n minus pj. We can say that the value will be n minus 1, right? So from this, what could we observe? We can observe that our final values will look like 1 n minus 1 followed by some n minus 1s. Either there could be some n minus 1s or some n minus 2s, right? This could be n minus 1, n minus 1. And in case, and after some value, the next value that we could get is the previous value minus 1, not lesser than that at any point. Because only one number can make change, right? So that is why it could be n minus 2 followed by some n minus 2, so on, right? So on till 0. So here the conclusion is number of zeros we get is exactly 1. Number of n minus 1s that we get is at least 1. And all other numbers in the range 1 to n minus 2 that we can get is zero to that number. Basically, it can be some valid positive number. It can either be 0 or some valid positive number. Either be 0, like any number in this range can appear 0 times or more than 0 times, right? So basically, if we see that to more than 0 times, in the sense, we can just say any number can either appear in the following ways. So apart from these two numbers, so one can appear 1 to n times. Okay, let's not call it as some range. Let us denote it as some. Let us denote it as any number in the range 1 to n minus 2 can either occur 0 times or more than 0 times. So these can occur 0 times also or more. And we don't know how many more times will it occur. So that thing we can calculate greedily. We can just process them greedily and then know how many times each thing can occur. So let's handle that later. For now, the main observations are 0 will occur exactly once, n minus 1 will occur at least once, and any number in the range 1 to n minus 2 can occur either 0 times or more than 0 times. Right? Now from this claim, if we just formulate it, we can observe that we'll get n minus 1 into some x1 plus x2 into x2 plus so on plus n minus 3 into xy, right? This value should be equal to k, right? Because we just observed uh, how the equality looks like. I mean, how the equation looks like at each point, and what will be the value from reverse at each point. So if we just quick formulate that, we'll get this value. So we can just write it as 1 into x1 plus 2 into x2 so on plus v into xy is equal to k minus is equal to n into minus k. Okay? So I just simplified the above equation. So this is what we get if we simplify. Now here x1 plus x2 plus so on plus xy is nothing but n minus 1 if you observe. Right? All these values are n minus 1. So this is xy n minus y. And we know that y is greater than, I mean basically y is some number which is less than or equal to n minus 1, right? Because y can't be equal to n. As from the observations we saw, 0 appears only once. It will appear exactly once. So from this, if we just formulate it, we get this is nothing but n minus 1. So if we just formulate it now, we get 2 into x2, 3 into plus so on plus y. So this is y into x2. And we don't know what is the y, which is ND. This will be equal to n into minus 1 minus 2. So let us consider this as some value, right? So now our aim is to find out whether there exists something of this sort with the following value, right? I mean, something which exists of this sort in the LHS, which is equal to the value. So if we just observe this equation, if we generate a n minus 1 at any jth point, that just means that from the RHS, we are subtracting a 1. Right? So just observe this equation, then you can observe if we generate n minus 1 at any point, that means we are subtracting a 1 from the RHS. Similarly, if you generate n minus 2, that means we are subtracting a 2 from the RHS. So until if you are generating n minus y, that means you are subtracting a y from the RHS, right? That's what it looks like. If you just observe this equation, which we derived. Now, if we see, this equation is sufficient enough for us to solve the problem, right? So, first basic condition that should hold is, so firstly, let's see how we can construct the permutation, and then let's go with the basic observation. So, firstly, to construct the permutation, we'll always fix 1 to the front. As if there are many ways we can construct in any way, I mean, we can construct any permutation and just print any, because if there are multiple solutions, we can do that, which is mentioned in the question. So that is why let's fix 1 and then try constructing the permutation. 1 at the front and try constructing the permutation. So for that, what we can do here is, firstly, let's say if we put a n here, that means all this will result in a 1 subtraction of 1 from the value, right? Where by value I'm referring to this RHS. The RHS is n into n minus 1 minus k. So by value I'm referring to this RHS. So now if I put a 1, that means we can say that no matter what we put here, we'll for sure generate n minus 1 as the value, n minus 1, n minus 1, n minus 1, so on till n minus 1, n minus n, n minus 1 here, right? So that means when we were making the observation, because of the equation that we formulated, from this equation we just got some RHS. So in the RHS, it just corresponds to, if we generate a n minus 1, that means we are subtracting 1 from value. If we generate a n minus 2, we are subtracting 2 from the value. If we are generating n minus y, then we are subtracting y from the value, right? This is how it corresponds to. So now we are making use of this mapping, and then our aim is to make the value 0. By subtracting some amount, we should make the value 0. Why? Because if you just bring LHS to the RHS, it just means subtracting value from LHS, right? So our aim is to make LHS equal to value. That means when we subtract, value should be 0. So from this mapping, if we observe, if we put an n here, that means we are generating n minus 1. If we are generating n minus 1, that means we are subtracting 1 from we are subtracting 1 from the value, which is the RHS. Now, so that means firstly, we can't have zeros, right? Because we know that the least number that we can generate is n minus 1 at least, right? But we can never generate 0. 0 can only appear once, and that will appear over here, right? So that is why, firstly, whatever value we got, value is nothing but n into n minus 1 minus k. So whatever value we got, this value should be greater than or equal to n minus 1. In case if value is lesser than n minus 1, we can say it's impossible to construct such a permutation. So in this scenario, it's minus 1. Right? So firstly, let us write out the basic condition, that is, if value is less than n minus 1, then it's impossible to construct the permutation. So it's minus 1. Otherwise, it might or might not be possible to construct. So let's see. So firstly, if value is greater than or equal, if value is greater than n minus 1, what we can do is we can just generate all ones over here, right? So to generate all ones, we can assume we kept n over here, right? So now if we put a n over here, our value will become n minus 1. Sorry, our value will become minus n minus 1, right? And now if our value is greater than n minus 2, then we can just replace n over here and then put n minus 1 over here. That just means that we generated the following, right? 2, 2, 2, 2, 2, 2, and then we generated a 1 over here. Because if you see till here, difference between the minimum and maximum element will be n minus 2, which means we are subtracting 2 from value. Till here, the difference between maximum minus minimum will be n minus 2 only. Till here also it will be n minus 2. And finally, at the end, it will be n minus 1, right? Because we know that for sure at least one n minus 1 will appear. So here at least one n minus 1 appear. Now for n minus 3 to appear, at least one n minus 1 and n minus 2 should appear, right? So it depends on the scenario. In case if we want n minus 3 to appear, that is if we put a 3 over here, it becomes till here it becomes n minus 3. And later on, firstly we should get a n minus 2, then only we can get a n minus 1, right? So now the way we'll be constructing this is the permutation is we'll greedily find this out. We want to make value 0. So for that, we can put some number of ones from right to left, then followed by some number of twos, followed by some number of threes. So basically, we should be able to put like this: 1, then a 2, 3, 3, 4, 4, something like this, right? So by adding such kind of values, we should be able to make LHS perfectly equal to value from the derived equation. So for that, let's take an example and then see how we'll be constructing it. So n is equal to 7, k is equal to 30. Let's consider this example and solve how we can construct the permutation. This is our p, let's say. So now, initially we'll always put a 1, right? Now, let us calculate what is this value. N into n minus 1 minus k, right? This is our value. So our value will be 42 minus 30, which is 12, right? So now value is 12. So we must arrange the sequence in such a way that will nullify this 12 that we have, right? So 12 is first basic condition is 12 should be greater than or equal to n minus 1, which is 6, and it is greater than or equal to 6. So till here it is valid. Now let's see. So now, in case if we put 6 over here, in case if we put 7 over here, then what happens is we'll basically subtract. See, because of putting 7 over here, we generated a subtraction of 1 from this subtraction of 1, because if the result is n minus 1, then we should subtract 1 from value. That is how the mapping was from the derived equation. So we had to subtract 1, 1, 1, so until we had to subtract 6. So because value is greater than 6, we can assume that we kept 7 as of now and then subtract it from the value. Then our value will be 12 minus 6, which is 6 over here, right? Now we know that we can have twos. We can subtract 2 n minus 2 times. So now we assume that we subtracted 1 from all these by putting a 7 in the field. Now what we assume is, we kept 7 here. We pushed 7 to the last and then kept 6. Then what happens is, if we see, last one will be 1, rest all becomes 2, right? Now let's see if we can actually make the value 0 now or no. Now from value we can just subtract 5, which is nothing but previously it is 6. By 5 in the sense, previously we subtracted all ones, right? Now because of adding 6, we subtracted ones for these positions only, 5 positions. So that is why value minus 5, which is nothing but 6 minus 5, that is 1. Now there is only 1 left. Now let's see, by pushing 6 to this and adding a 5, could we make value 0? But if we do this, what happens is 3 gets added to 4 positions. That means we'll be subtracting 4 ones. So because we are subtracting 4 ones, instead of subtracting 4 ones, we could just restrict the movement of 6, right? So if we subtract 4 ones, by doing this, value goes negative, right? But we can actually restrict subtraction of ones in the range 0 to 4 by using this 5, right? 5 will always be present here, but by just moving the 6 elements position to the front, we can just restrict the number of ones we are subtracting. So here, if we do this, then we had to subtract. Now the value is 1. From 1, we had to subtract 4, right? Because we subtract 1 from all this. Instead, what we do is, we can just move 6, then we just subtract 3 times. If we move the same 6 over here, then we only subtract 2 times. If we move the same 6 over here, then we'll be subtracting only 1 time, right? We want to subtract only 1 time. So now we just subtracted it 1 time. This became 3. So here we perform 3 subtractions from value. Here we performed all these. We performed 2 subtractions, and here we perform 1 subtraction from the value. Right? So now we know. Now this is sufficient to. This is sufficient by just having these positions fixed. We can always generate k is equal to 30. I mean, we could always generate the equalities result to be equal to 30. So, and in the empty positions, we can put any of the numbers. So I'll just put 3, 4, 1, 3, 4, 2, right? So here, no matter what we put, it doesn't matter, right? So I just kept 3, 4, 2. I mean, put all those which are left over, and you can put it in any order. So that is why this is 3, 4, 2. And if we observe, till here the value is 0. Now here, if you see, the value is 4, right? Minimum, basically we are just checking if this is a valid permutation. Till here it is 0. Till here maximum minus minimum value is 4. Till here maximum minus minimum value is 5. Till here it is 5. Till here it is 5. Till here it is 5. And till here it is 6, right? So if you just sum it up, we got it equal to 30. So this way we can just reformulate. This way we can just formulate. This way we can just formulate with the observation that from the if we consider the whole permutation, the result of maximum element in the permutation minus minimum element will be equal to n minus 1. And excluding the last element, if we consider it, it might be n minus 1 or n minus 2, depending on what we kept in the last element. So this way we can just consider. This way we can just consider that we'll have a sequence looking like this. That is, at the end, some n minus 1s followed by some n minus 2, so on till some n minus y values, right? And at last we'll have exactly 1, 0. That is in the front. So from this observations, we could just formulate it, and we could just derive this one. And from this LHS and RHS, we could just greedily construct the value, right? We could just greedily construct the permutation by making some subtractions based on what element we put, right? So now similarly, let's try out for n is equal to 7 and k is equal to we could try out for k is equal to maybe 10, right? So let's see if this is possible or not. Right? So we have a 1 here. We are just putting 1 in the way we are constructing. Now value is 49 minus 10, right? Not 49, 42 minus 10. which is 32. So now let's see. Now, in case if we put a 7 over here, we'll be subtracting ones from the value, all ones from the value. So value will be equal to val minus 6, which is nothing but 32 minus 6, that is 26. Now, if we push 7 over here and put 6, then we'll subtract 1 from all these positions. So here value will be equal to val minus 5, which is 21. Now, if we push the 6 over here and put a 5, then value will be equal to minus 4, which is equal to 70. Now, if we push this 5 over here and if we push, because of putting a 5 here, these all became 3. Here we had to perform 3 subtractions from these symbols. Now, by pushing the 5 over here and putting a 4, these 3 will become 4, 4, 4. We perform 4 subtractions, so it is value minus 3, because we subtracted 4 from 3 indices, so that is 14. Now, if we push 4 over here, and if we put a 5 over here, then value would be equal to from these two we'll subtract 5, so minus 2, which is 12. And finally, value is equal to, if we push this 5 over here and put us, sorry, previously it's not 5, we get the 3 here because the next smallest. So if we put a 3 here, it's 5, 5. Now we'll push the 3 over here and put a 2 over here. Then what happens is we get 6 over here. Okay? So the value is value minus 1, which is. Now, if we see, so after putting the sequence in this fashion, still if we couldn't make the required RHS 0, then we can say it's minus 1. If value is greater than 0, then we can say it is impossible to make, because this is the best value that we could get, right? So instead of handling it while constructing the permutation, you could even handle it beforehand. That is, from this only we could observe by just putting 1, 2, 3, 4, 5 consecutively, what values will be generating? Will be generating 6, 5, 4, 3, 2, 1, right? So basically, if value is lesser than n minus 1, then it is a minus 1. Or if value is greater than n into n minus 1 by 2, because it's sum of natural numbers, then also it is minus 1, right? If value is in between these two ranges, then we could always construct a permutation, right? So which we already saw how we could construct the permutation, considering n is equal to 7 and k is equal to 30. So like hints to implement this is find out what is value first, and then just perform the greedy process. That is, if you put the largest value over here, then how much do you subtract from the value? If that's after subtracting that amount, still the value is positive, then you can always subtract that. Right? That is beneficial. So subtract that, and you are able to subtract the value by putting the highest value over here, then just subtract that amount and put your value to the end, and then try for the next largest element, because because you want more number of ones to get subtracted. Right? So that is why we push the largest value here and we put the next largest value here, which will ensure that you perform more subtractions on value. And at max, number of subtraction we could perform are n into n minus 1 by 2, which we already saw. So by taking this example, we just saw how this is actually working and why is it actually n into n minus 1 by 2. Right? So calculate value, then greedily first try basically first element always fix it as 1. And in the second element, try making choices. Firstly, place the largest number and then check if you could actually if you could make the value 0 by performing the following subtraction. If you still have some positive value, then push that largest value to the uh, last, to the end. By end, I mean if you are placing n here, then push it to nth position and then try for n minus 1. If you are placing n minus 2 here, then push after n minus 1. Still, if you couldn't get the value, required value, I mean, still if you couldn't make value as 0, then push this n minus 1 to n minus 1th position. So basically, push it to n minus 1 and then put n minus 2, because this will ensure you're subtracting 3 from this, 2 from this, and 1 from this, right? So this is how the cycle is happening. That is, if you just observe, when you put n here, one subtractions from each of them, one subtraction will happen. If you push n and put n minus 1, then for all these indices, a subtraction of 2 will happen. If you put n minus 2 and push n minus 1 here, then for all these indices, subtraction of 3 is happening from the above LHS and RHS that we derived. Now, if you put n minus 3 here, 4 is getting subtracted, 3 is getting subtracted. Right? Now, if you observe, if you don't want to subtract 4 from 3 indices, what you could do is just move this n minus 2 to the front. Then what's happening here is you could just restrict the number of 4s you are subtracting. Right? And similarly, move it by one more step, then you can observe this is also becoming 3. So here you are only performing subtraction of 4 on one index. That means in value, only one subtraction will happen. Right? Just like how we saw while constructing the permutation for this case. So greedily find out, move from the largest number that you have and try out placing that number here and see how many subtractions do you need. So basically, if you could subtract that amount from value, then subtract. If you don't want those many subtractions and if you want lesser subtractions, then just move the element to the point where basically, let's say you need, after placing n and n minus 1 here, you need only 2 subtractions. Right? If you need 2 subtractions, then you can place n minus 2 here and then place n minus 1 over here. This will ensure you'll subtract from this and this. So 2 subtractions will only happen. And for sure, a case where at a point you need some number of subtractions which are less than or equal to the current number will always occur. Why? Because we already handled the invalid cases. That is, if value is lesser than n minus 1, it's impossible, and if value is greater than n into n minus 1 by 2, it is impossible. Right? So that means at a point, value will for sure be less than or equal to the thing that you need, that you want to subtract, that you can subtract. So can subtract depends on what value you are putting here. Will for sure, this case will for sure occur at a point. Right? So this way you could just implement fix one and iterate from largest number to smallest number and greedily place the numbers based on what is the current value after making the greedy subtraction. Okay? So now if we look at the time complexity of this, time complexity of it would be big of n, as we just iterate a loop and then construct the array, and we just formulated to calculate value, we can just calculate it O1. And if we look at the space complexity, we need big of n space, assuming that we are using a array to store the permutation and then to print it. So this is per test case. So if you see test cases are 10 power 6 given, it is guaranteed that summation of n is less than or equal to 10 power 6. So this means you can assume there is one test case with n is equal to 10 power 6. So this is sufficient enough to pass in, this time complexity is sufficient enough to pass in 1 second of TL. And the space complexity is sufficient enough for the given memory unit. So this way you can solve the problem with a time and space of big of n.